Hello and welcome to Tech Talk Today, where we cover the latest in tech and AI in plain English. It is an initiative of AI Square.f powered by Dhruv.ai. In this episode, we cover an interesting research work in AI which promises to make machines understand abstract concepts like humans do. Fascinating, isn't it? Let's dive in.
Okay, so get this. Imagine AI that understands information, not just word by word, but idea by idea. And not in just one language, but across hundreds.
Wow.
We're talking next level stuff here.
Yeah.
Large concept models.
LCMs.
Or LCMs.
It's a really different way of thinking about how AI processes language.
Yeah.
It's like we've been building houses with just bricks.
Okay.
And now someone's figured out how to use prefab walls, you know?
That's a great analogy. And we're diving deep into this new approach.
Okay.
With a research paper straight from the source.
That's good.
Large concept models, language modeling in a sentence representation space from the LCM team at Meta AI.
What's fascinating here is that the paper argues that the way we've been approaching language AI with large language models, LLMs might be fundamentally limited.
Oh, interesting.
LLMs are great at predicting the next word.
Right.
But they don't really grasp the meaning behind those words.
So it's like they're just playing a sophisticated game of Mad Libs, but not truly understanding the story they're telling.
Exactly.
Got it.
That's where LCMs come in.
Okay.
They treat entire sentences as single units of meaning, concepts. It's like taking a whole paragraph and compressing it into a single idea.
But how do you even represent a whole sentence as a single concept?
Yeah.
It's not like you can just cram all the words together.
That's where this thing called sonar comes in.
Sonar.
It's a pre-trained sentence embedding space.
Okay.
Think of it like a giant library,
right,
where each sentence in over 200 languages has its own unique code.
Wow.
Like a Dewey Decimal Number for meaning.
Wait, over 200 languages?
Yeah.
So you're saying these LCMs could potentially understand and translate between all those languages?
That's the idea.
Wow.
It's something LLMs struggle with,
right,
since they're often trained on a single language, usually English.
This is already blowing my mind.
Yeah.
And we're just getting started. So how do these LCMs actually work?
Okay.
Walk me through the process.
Imagine you feed an LCM some text.
Okay.
First, it breaks the text down into individual sentences.
All right.
Then it uses sonar to encode each sentence into a concept embedding.
So each sentence becomes like a point.
Yeah.
In this vast multidimensional space of meaning.
Exactly.
Okay.
And the LCM's job is to predict the next concept based on the previous ones. Just like LLMs predict the next word.
Okay, I'm starting to get it.
Yeah.
But instead of predicting the cat sat on, it's predicting whole ideas like the cat was relaxing on the mat.
That's a good way to put it.
Okay.
And because it's working with these larger units of meaning, it's actually much more computationally efficient than LLMs.
Oh, cool.
Especially for longer pieces of text.
That makes sense.
Yeah.
If you're dealing with fewer units. You need less processing power to make predictions.
Right.
So less compute, more meaning.
Exactly.
That's a win-win in my book.
But
I have to ask, if these concepts are just represented by numbers, how do we even know if the LCM is doing a good job?
Well, the researchers tested several different LCM architectures.
Okay.
The simplest one, the base LCM, uses a straightforward regression approach.
All right.
It tries to predict the numerical embedding of the next concept as accurately as possible.
So it's like aiming for the closest match in this concept library.
Right.
Cool.
But they also experimented with more complex architectures.
Okay.
Like diffusion-based LCM.
Diffusion-based LCMs.
Which are inspired by how AI generates images.
Okay, now you've officially lost me.
Oh, no.
What does image generation have to do with understanding concepts?
It's about learning the underlying patterns and relationships between concepts.
Okay.
Imagine taking a picture and slowly adding more and more noise to it until it's just static.
Okay.
A diffusion model learns to reverse that process.
Interesting.
Starting with noise and gradually refining it until it reconstructs the original image.
So it's like learning to see the signal through the noise?
Yes.
But in the world of ideas.
Precisely.
Wow.
And it turns out that these diffusion-based LCMs were actually the best performers in the study, especially for creative tasks like generating stories.
Wow, that's fascinating.
Yeah.
So they're using this noisy image analogy to figure out how concepts flow together and create meaning.
Exactly. It's about learning the probability of one concept following another, kind of like a sophisticated game of connect the dots.
Right.
But with ideas.
I like that.
They also tested a quantized LCM, which breaks the concept space into distinct categories, making it a bit easier to handle computationally.
So it's like simplifying the concept library.
Yeah.
Organizing it into different sections instead of having everything spread out on one giant shelf.
That's a good way to think about it.
Yep.
But here's where it gets really interesting.
Oh, good.
They tested the LCM on a task called zero-shot multilingual summarization.
Zero-shot multilingual summarization.
Basically, they gave it text in 42 different languages.
Okay.
And asked it to summarize it in English.
Hold on.
Yeah.
But I thought you said these LCMs were only trained on English data.
That's right, they were.
Okay. But remember, Sonar itself can handle over 200 languages.
Right.
So even though the LCM hadn't seen those other languages during training, it was still able to understand and summarize them.
Wow.
Often outperforming a dedicated multilingual LLM.
That's incredible.
It is.
It's like cracking the code of language itself.
Yeah.
So are you saying that LCMs could potentially learn to speak any language just by understanding the underlying concepts?
That's one of the exciting possibilities this research opens up.
Wow.
It suggests that LCMs could be much more adaptable and versatile than we initially thought. This is way more than just predicting the next word.
Right.
We're talking about a whole new level of AI understanding.
Yeah.
But I'm guessing it's not all smooth sailing.
Well, there are definitely challenges.
What are some of the challenges the researchers are facing with these LCMs?
Well, one of the most interesting findings was the fragility of certain concepts.
Fragility.
Yeah.
Like some concepts are more delicate than others?
Exactly.
Right.
They discovered that even tiny changes to a concept's embedding could completely alter its meaning when it's translated back into text.
Huh.
Some concepts are robust. Yeah. Their meaning stays consistent.
Right.
But others are very sensitive.
So it's like playing a game of telephone.
Yes.
Where some messages get garbled more easily than others.
Exactly.
It makes you wonder, what makes certain ideas so sticky and resistant to change?
Yeah.
While others are so easily distorted?
That's a great question. Yeah. And it's something the researchers are still trying to unravel. This fragility poses a challenge for training LCMs.
Right.
Because it means the model has to be incredibly precise in its predictions.
It makes you wonder if this fragility tells us something about how we humans process information, too.
Yeah, definitely.
Do we have certain ideas that are more firmly anchored in our minds than others?
That's a really intriguing thought.
Yeah.
It suggests that our understanding of concepts might be much more nuanced and dynamic than we realize.
This is already making me see the world in a new light.
Uh-huh.
And we're just scratching the surface.
I know, right?
What else did the researchers uncover in their deep dive into LCMs?
Welcome back to our deep dive into large concept models.
Before we went down this rabbit hole of concept fragility,
right?
You mentioned that the researchers tested different ways to deal with this issue. What did they find?
One approach was to simply filter out the most fragile concepts from the training data.
So it's like removing the wobbly blocks from a Jenga tower.
Yeah, kind of.
Makes sense. But it seems like you'd eventually want to handle even those tricky concepts, right?
Of course. That's where they started to look at ways to improve the Sonar decoder itself.
The decoder?
Remember, the decoder is what translates those concept embeddings back into readable text.
Right.
If you can make the decoder more resilient, it could potentially handle a wider range of concepts, even the fragile ones.
That's clever. So instead of avoiding the problem, they're trying to build a better tool to handle it.
Exactly.
Did it work?
They had some success by fine-tuning a new Sonar decoder specifically on those noisy concept embeddings.
Interesting.
They were able to significantly improve its ability to handle those trickier cases.
Okay, that's pretty encouraging.
Yeah.
But let's zoom out for a second.
Okay.
Besides this whole concept fragility thing, what are some of the other big challenges on the horizon for LCMs?
One of the major ones is scaling up.
Scaling up.
The models they tested in this paper were relatively small.
Okay.
Around 1.6 billion parameters.
1.6 billion.
That pales in comparison to some of the massive LLMs out there, which have hundreds of billions of parameters.
So it's like the difference between a model airplane and a jumbo jet.
In a way, yes.
Yeah.
Larger models generally tend to be more capable, especially when it comes to complex tasks and generating creative text formats.
Right.
But as we discussed before, LCMs have a built-in advantage.
Right.
Because they operate on concepts, not individual words.
Right. So they're working smarter, not harder.
Exactly.
Does that mean they don't need to be as gigantic as LLMs to get similar results?
That's the hope.
Okay.
The researchers are working on scaling up LCMs to see how far they can push the boundaries.
Interesting.
They've already trained a 7 billion parameter model.
7 billion?
And early results are promising.
7 billion? That's a huge leap from 1.6 billion.
It is.
What kind of new things can this larger model do?
Well, it starts to excel at tasks like summarization.
Summarization.
And something they call summary expansion.
Summary expansion. Now, hold on a second.
Okay.
Before we go any further.
Yeah.
Remind me what kind of summarization we're talking about.
Yeah.
Are we talking about pulling out key sentences from an article? Or more like paraphrasing the main points in a new way?
It's more about capturing the essence of a document.
Okay.
Creating a concise and coherent summary that conveys the key information.
Right.
Without just copying and pasting.
Ah, so it's like having your own personal AI Cliff's Notes.
Exactly.
Sign me up. But I'm still a bit puzzled.
Okay.
Didn't we say that LCMs weren't designed to work at the word level?
Yeah.
How can they generate a smooth and readable summary if they're thinking in these big, chunky concept blocks?
That's where the sonar decoder comes in again.
The decoder.
It's responsible for translating those concept embeddings back into natural language.
Okay.
And the researchers have been hard at work making the decoder more fluent and coherent.
So it's like the decoder is the smooth-talking spokesperson for the LCM's brilliant but abstract ideas.
I like that.
Makes sense. And what about this summary expansion?
Yeah.
What's that all about?
It's like the reverse of summarization.
Okay.
Imagine you have a short summary and you want to expand it into a longer, more detailed text.
Right.
Like turning an outline into a full-fledged essay.
So it's like taking the SparkNotes version and transforming it back into the original novel.
Haha, exactly.
That's impressive.
The LCM showed real potential with this.
Okay.
It could take those short summaries and flesh them out with relevant and coherent information.
This is really making me rethink what AI is capable of.
It is exciting stuff.
It sounds like LCMs could change how we interact with information completely.
It has the potential to, yeah.
But I need to see it to believe it.
Okay.
Can you walk me through a concrete example of an LCM in action?
Sure. Let's say you give an LCM the prompt.
Hi.
A young girl named Alice is walking through the woods.
Okay, that's our starting point.
Yeah.
What happens next?
The LCM takes that sentence and encodes it into a sonar concept embedding.
Right.
The embedding captures the essence of the sentence.
Right.
A girl named Alice, the act of walking, and the setting of the woods.
So it's not just understanding the individual words,
right,
but the whole picture they create together.
Exactly.
Got it.
Then, based on this initial concept embedding,
okay,
the LCM has to predict what comes next.
Right. But there are infinite ways the story could continue.
Yeah.
Right. Alice could stumble upon a magical creature, or get lost, or find a hidden treasure. The possibilities are endless.
And the LCM's job is to generate a concept embedding that represents the most likely continuation of the story.
Okay.
Based on what it knows about language, storytelling, and common sense.
So it's drawing on all its training data to make an educated guess about what happens next.
Precisely.
Got it.
And let's say the LCM predicts a concept embedding.
Okay.
That represents the idea of Alice seeing a white rabbit running past. The sonar decoder would then translate that embedding into a sentence. Like, suddenly a white rabbit darted across her path.
And the story unfolds from there, one concept at a time.
That's right.
Cool.
The LCM keeps predicting those concept embeddings. And the decoder keeps translating them into sentences.
Right.
Weaving together a complete narrative.
It's like the LCM is the brain behind the story.
Yeah.
And the decoder is the voice that brings it to life.
I like that analogy.
This is incredible.
It is very interesting research.
It seems like this approach could be used for all kinds of creative tasks.
Absolutely. The potential applications are vast.
Before we explore those,
okay,
I'm curious, what aspects of this research have stood out to you the most so far?
That's a good question. Well, honestly, the potential for LCMs to break down language barriers?
Yeah.
I mean, the fact that they can summarize text in languages they've never even seen before is just...
muggling.
Yeah.
It's wild.
Like what? Yeah. It's a testament to the power of working with concepts rather than just words.
Right.
It points to a future where AI could seamlessly understand and generate information across languages.
Yeah.
Opening up so many possibilities for communication and collaboration.
This whole conversation has me thinking.
Yeah.
What are some of the real-world applications of this technology? It's cool to talk about the science, but I'm curious how LCMs could actually impact our lives.
Well, imagine a world where you could instantly translate any document, any website, anything into any language.
Like a universal translator straight out of Star Trek.
Exactly.
Yeah.
It's not as far-fetched as it sounds.
Right.
And it goes beyond just translating words.
Okay.
Think about researchers trying to make sense of scientific papers from all over the world.
Yeah.
Or students trying to grasp complex topics from textbooks. LCMs could help us quickly distill the most important information and connections.
Right.
Saving us a ton of time and effort.
Okay, that would be a game changer for anyone who's ever felt overwhelmed by information overload.
Right.
Which, let's face it,
Yeah.
is pretty much everyone these days.
Exactly. And it's not just about efficiency.
Right.
LCMs could help break down communication barriers between people from different cultures and backgrounds.
Yeah.
Imagine the possibilities for fostering understanding and collaboration.
It's like using AI to bridge the gap between human minds. I love that idea.
Yeah.
But let's not forget the creative potential of LCMs.
Right.
We've already talked about storytelling.
Yeah.
But could they be used for other types of content creation too?
Absolutely. Imagine personalized stories tailored to individual interests. Or educational materials that adapt to different learning styles.
Yeah.
We could have AI that creates truly unique and engaging content.
Right.
Moving beyond those generic templates we see so often.
So instead of just churning out the same old stuff, AI could actually become a powerful tool for creativity and innovation. But as with any powerful technology,
Yeah.
there are potential downsides to consider.
Of course.
We need to be mindful of the ethical implications.
Right.
What kind of ethical concerns are we talking about here?
Well, for one, there's the potential for misuse.
Okay.
LCMs could be used to generate incredibly persuasive propaganda or create deepfakes that are even harder to detect than the ones we see today.
That's sobering thought.
Yeah.
It seems like we need to tread carefully and think about the potential consequences before unleashing this technology on the world.
Absolutely.
It's like we're at a crossroads. We have this incredibly powerful tool at our fingertips,
Yeah.
but we need to make sure we're using it wisely and responsibly.
I couldn't have said it better myself.
So as we wrap up this episode, what's the one big takeaway you want our listeners to ponder?
I think the biggest lesson from this deep dive is that intelligence is more than just processing words.
Right.
It's about understanding concepts, making connections, and creating meaning. And as we continue to push the boundaries of AI, it's vital that we keep those uniquely human qualities at the forefront of our minds.
Beautifully said.
Thank you.
That's all the time we have for today's deep dive into the world of large concept models.
Okay.
We encourage you to check out the research paper we discussed and keep exploring this fascinating field.
Yeah.
Who knows, maybe one day you'll be the one developing the next groundbreaking AI technology.
That would be awesome.
Until next time, keep diving deep and keep asking questions.
Thanks for listening.
Before we say goodbye for now, I hope you had an interesting learning today with us. Our acknowledgements and thanks are due to Facebook AI Research Group at Meta, who have proposed large concept models. Only time will tell whether it lives up to the promises it is showing up right now. We have also provided the link to the research paper as further reading in the description. Do join us for our next episode, where we again take up really interesting work at the cutting edge of tech and AI and unravel it for you. If you enjoyed this, please do encourage us by liking, commenting, subscribing, sharing, and spreading the word around. Ciao.